2 and 1. Okay, so this particular example haunts a lot of students, teachers, profs for quite a bit. So you have to kind of take a look at it. It's a pretty famous one. If you've run into probability at some point, you might have this one. It's a great question, to tease your friends with. Most people will not be able to get this question right away. It's a little bit harder, but once you break it down, it should slowly start to make sense. So I'll try to do that. So you are on a show to win, let's say, $100 million. Now, the prize is irrelevant. Okay, sometimes they'll say, there's a donkey behind the door or something like that. The host shows you 3 doors. Okay, so you have 3 doors. Behind one of those doors is the prize. The other 2 doors leave you with nothing. So the host asks you to pick a door. So let's say you pick door number 1. Okay, which door you pick doesn't matter. The host opens a different door with nothing behind it and asks you, do you want to switch your choice? Should you? So for most people, when they think about this problem, all right, so you have 3 doors. Now, if you're just imagining this, okay, so let's say we have door 1, here's door 2, here's door number 3. If you pick a door, and let's say in this case you pick door number 1, and then the host opens a door which is empty, that means there's only 2 doors left. And in those 2 doors, right, and behind one of those doors is the prize. So it seems like, you have really a probability of 50% chance of winning. Okay, so, staying or not staying, it seems like it doesn't really matter. But it's a little bit more than that, because this is kind of a conditional probability. The condition is that the host will always open, now after you make your choice, because they know where the prize is, so they will always open the empty door. Okay, so let's imagine, so we have these 3 doors. Now, what can happen with the 3 doors? So I'm going to take this, I'm going to duplicate it. Okay, so there's really just 3 different alternatives here. So let's duplicate it again. So here are my 3 choices. All right. Now, the winning prize that you have, so your $100 million in this case, it can be, so either, okay, so here's your prize, it can be behind door number 1. That's one of the things that can happen. Of course, it could be behind the door number 2, or it could be behind door number 3. Now, you don't know where it is because their doors are closed. So let's say that you make a choice, okay, within here. And what I'm going to do is I'm going to kind of break this down into a table. All right. So let's say, all right, so that this particular item, okay, so this number 1, okay, let's call this number 2. Okay, so these are all the different possibilities that can happen. And then we're going to calculate what the probability actually is. So let's say it was number 1, all right, and then you pick that particular door. Okay, so here is your pick that you have. Now, obviously, because the price is there, now we know that beforehand. Okay, and then you would say, well, I don't want to switch, right? But if we knew that, then that defeats the purpose because we don't know where the prize actually is. Now, in this particular case, all right, so what will happen? Okay. Because what we want to find out is, should we switch or not switch? So let's say that we switch. All right. So if we switch here, we know we're going to lose, right? Based on this. Okay. So we would have lost here if we switched them. Would have hurt a lot because the host would have opened either, this door or this door. It doesn't really matter. Okay. So we lost there. Now, what if it was the second situation? You know, so we picked our door. So this is so we're going to stick, you know, with the same door always. So we're picking the first one. Okay. Now, in this particular case, so in the second case, notice because you picked the door number 1, the host really can only pick this door, right, to open, because there is no prize behind it, and that's exactly what it says in the question. So if they're going to be picking that door, then you switching, you would actually win. Okay, so that would make you a winner here if you switched. Now, the last situation, so that you have, all right, so again, you're stuck on the first door. So should you switch or not? And notice again, the host has no choice but to pick this door. And therefore, if you switched, you would win again. So look what happens if you switch. 2 out of the 3 times, so the probability is 2 out of 3, and not 1 out of 2, which is a half, which is what most people think. So switching would allow you to win 2/3 of the time. So should you switch? Yes, you should switch based on probability. Of course, you know, if the first thing happened, you switched and you lost, now losing by switching, so that means, okay, your probability of losing if you switched is only 1/3. Okay, so that's what losing would be. Winning, your probability, so I should put this in here, make it more. Okay, probability of winning if you switch is actually 2/3. And this just breaks it down to you. So yes, I mean, it's definitely worthwhile to try to switch and then win the prize. Now, if you're going to get the 100 million, I guess you're pretty much done. Okay, and then you can go off and do whatever it is that you need. So I like this question a lot, and it really shows how bad we are with probabilities. Like, we really have to kind of draw it out and then see exactly what the situations are, because our intuition fails us, right? So, you know, you would think that, all right, you only have a half chance, and that's exactly what I thought when I first saw this question. I mean, it didn't seem to me that I should switch or not. It didn't really matter. But if you break this down and then see, okay, the conditional probability happening, okay, then you notice that probability of winning in switching is actually higher, okay, than it is by staying. Okay, so thanks for watching, and we'll see you in a future video. I hope you found this useful. Maybe somebody will subscribe based on this one. Okay, cheers everybody. Bye. See you at 1 million.